Hello students, as we are studying solution chapter and we are going with the topic colligative properties. So the next colligative property I am going to take today is the osmotic pressure. Okay? So first we must know what is osmosis. Then only you will understand osmotic pressure. Okay? So this osmosis term, in order to make you understand this osmosis, let me give you very simple example. Okay? So with that example, you will understand what is osmosis. Let's take the example of grape. Okay? Example of the grape, that if you are nowadays it is coming, okay, during summer season. So you just take the grapes and dip it in water. Okay? Take the container and take water also in the container and dip grapes in it. And you keep it for at least 3 to 4 hours. And then take out the grapes and then you observe it minutely. What you will observe, that the outer membrane of the grapes burst, crack. Okay? Burst or crack. One example. Second example, you just take kishmish raisins. Okay, and you dip it in water. Okay, and observe it just after 15 minutes. What you observe? Yes, that this kishmish or the resin swells up. Okay, it swells up. So what happened in these two processes? In these two processes, what happened? That the movement of the solvent take place. Okay? Movement of the solvent, it takes place. So let's understand now what is osmosis. So in case of this kishmish or the resin, what happened? That the water from this container, इस container में जो पानी था, ठीक है? Water from this container moved inside the kishmish or the resin. ठीक है, इसके अंदर पानी गया. And what happened in case of the grapes? That grapes, inside the grapes, what sugar solution is present? This solution is concentrated and outside in the container only water is present. ठीक है, outside in the container only H2O, water is present, but inside the grapes sugar solution, concentrated solution. So here also the movement of the solvent molecule take place from outside to into grape. ठीक है, but in both the cases the movement of the solvent or the movement of the water molecule take place through a membrane. ठीक है, membrane of the cell. ठीक है, and this membrane, it allow only solvent molecule to pass. ऐसा नहीं होता है कि जिसमें आपने ग्रेप्स को डिप करके रखा, दिस आउटसाइड वाटर इट बिकम स्वीट. ऐसा कभी नहीं होगा दैट द शुगर फ्रॉम द ग्रेप्स कम आउट और द शुगर फ्रॉम द किशमिश कम्स आउट. सो दिस मेम्ब्रेन, जो सेल की मेम्ब्रेन है, इट अलाउज ओनली सॉल्वेंट मॉलिक्यूल्स टू पास थ्रू इट. ठीक है, इट अलाउज ओनली हाफ मॉलिक्यूल, दैट ओनली सॉल्वेंट, नॉट द सोल्यूट. मीन्स दिस मेम्ब्रेन इज selective in nature, partial in nature. It allows only few molecules, that only solvent molecules. So that is why this membrane is called semi-permeable membrane. Semi मतलब half, आधे particles को allow करती है. Permeable मतलब allow करती है. So that is what is called semi-permeable membrane. आगे बात समझ में. So now let me define what is osmosis. Osmosis, it is the movement. अपने आप movement हो रहा है ये पानी का. So spontaneous movement of solvent molecules. Spontaneous movement of solvent molecules from dilute solution to concentrated solution. It means in the container outside this solution is dilute and inside the grape the solution is concentrated as the sugar solution is present. So movement of the solvent takes place from dilute to concentrated. किसके थ्रू गई? Through semi-permeable membrane. So this process is called osmosis. This process is called osmosis. Important is semi-permeable membrane. Remember, in case of osmosis, the presence of the membrane is must, that is semi-permeable membrane. This is what your osmosis. Okay. So I think it's clear to all of you that what is osmosis process. Now what happened? For example, let's take this one in order to understand the osmotic pressure. Okay. So here the container is there. Inside this container, water. Okay. Simple water is there. That is why it is written solvent. Here one tube is inserted, and at the end of this tube, semi-permeable membrane is attached. Okay. Semi-permeable membrane is attached. This semi-permeable membrane can be any cell membrane, egg, semi-permeable membrane, shell of the egg. Okay. After removing that calcium carbonate shell, white shell, you get one thin, okay, membrane. In case of egg, that thin membrane after calcium carbonate shell, that membrane also behaves as semi-permeable membrane. A gallbladder membrane, that can be also used as a semi-permeable membrane. And many chemically prepared semi-permeable membranes are also there. That is copper ferrocyanide. Copper ferrocyanide membrane is also a semi-permeable membrane. Okay? So many artificial semi-permeable membranes are also there. So here gallbladder, okay, membrane. It acts as a semi-permeable membrane, and inside this tube saturated solution is there, or I can say concentrated solution is there. Sugar solution हमने लिया और ये solution कैसा है? Concentrated है. So outside dilute solution, inside this tube concentrated solution. Here semi-permeable membrane. As soon as this membrane and the solution comes in contact with the solvent, what happened? The particles from the beaker starts moving inside this tube. इस tube के अंदर यहाँ से बाहर से पानी आने लग गया. So as the molecule entered this tube, the level of the solution in this tube starts rising up. Rise होने लग गया, बढ़ने लग गया. ठीक है. And after reaching a certain height, for example, यहाँ तक पानी आया ऊपर, solution की increase होती है level, and after this much level, there is no further increase in the level of the solution in this tube. There is now no more osmosis, क्योंकि यहाँ पे osmosis ही हो रहा था, अब osmosis नहीं हो रहा है, रुक गया. What happened actually at this position? At this position, when the process of the osmosis stops, at this time, this extra height, this much height of the solution, ठीक है, this much height of the hydraulic pressure, because water है, solution है, so I can call that this column of the water exerts pressure downward towards the semi-permeable membrane. All the particles which are present in this tube, they are exerting pressure. यहाँ से नीचे pressure आया, यहाँ से नीचे pressure आया, और direct pressure किसके ऊपर आया? इस membrane के ऊपर pressure आया नीचे से, and now this pressure stops the movement of the solvent molecule from outside to inside. That pressure is sufficient to stop the movement of the solvent molecule from inside the outside, and that extra hydraulic pressure which stops the movement of the solvent molecule from dilute solution to concentrated solution through semi-permeable membrane is called osmotic pressure. Is called what? Osmotic pressure. I think it's clear to everybody what is osmotic pressure. Now see the definition of the osmotic pressure. External pressure has to be applied on the solution. बाहर का pressure था ये, applied onto the solution to prevent the osmosis of the solvent through semi-permeable membrane is called osmotic pressure. It's clear to everybody? So I can explain you through this diagram also. Here the two, okay, H shape, this is the H shape diagram. Okay, two containers are there, and these two containers are separated with the help of a connecting tube, and in between the connecting tube a thin membrane is there, and this thin membrane is semi-permeable membrane. Partition done with the help of semi-permeable membrane. one arm of the H, it contains solvent, matlab simple water. Other arm of the H contains the solution, that is sugar solution. So as soon as these two arms of the H comes in contact with each other through the semi-permeable membrane, what happened here? Here also the same thing, that the particles of the solvent starts moving from this bulb, this arm to this arm. Okay, movement of the particle take place. So particles started moving towards the concentrated solution, and what will happen? That the level of this solution increases in this arm. इसमें लेवल इंक्रीज होने लगेगा, ऊपर जाने लगेगा और ये वाला नीचे जाने लगेगा. Is it clear? Because solvent is moving from this to this. So this level will go down, this level will go up. And after reaching certain height, this process stop. मतलब यहाँ से for example इतनी height तक गया, उसके बाद में रुक गया. Why it is so? Because that extra hydraulic pressure is enough. Downward pressure is exerted. That pressure will go to the semi-permeable membrane and it will stop the process of osmosis, and that extra pressure is called osmotic pressure. So terms are clear. I think osmosis समझ में आया. I think it's clear to you. Osmosis is clear. What is semi-permeable membrane? This is also clear, and osmotic pressure is also clear to you. Okay, fine. So now this osmotic pressure, it depends upon the number of the solute particle. Obviously कि भैया कितने अंगूर मीठे थे उसके ऊपर डिपेंड करेगा कि कितना पानी बाहर से अंदर जाएगा. Obviously what is the concentration of the solution inside this tube will decide how much water from inside will flow, from outside will flow inside. ठीक है? So it depends upon how much NaCl or how much sugar is dissolved in the solution. So this is what we have written, that it depends upon the number of the solute particle or molarity. यहाँ पर हम ध्यान से देखेंगे. Till now whatever I taught you the colligative property, that colligative property depends upon molarity, but osmotic pressure is the only colligative property that depends upon the molarity, capital M. ठीक है, fine. So it depends upon the number of the solute particle or the molarity. So this osmotic pressure, okay, relationship with the temperature, volume and concentration is same as ideal gas equation. Is same as ideal gas equation, and it is applied for very dilute solution. When the solution is very dilute, then it obeys ideal gas equation. Ideal gas equation in the 11th class we have studied. So all of you remember that was PV equals to nRT. Pressure, volume, number of moles of the gas particle, R is the gas constant, T is the temperature. Okay, so it follows ideal gas equation. So the difference is this much only, that here the pressure P, instead of the P here we are representing pressure, that is osmotic pressure of the very dilute solution with pi. हम pi से P को replace करें, यही difference है. So pi V equals to nRT, pi equals to n upon V RT. N is the number of the moles of the particles present in the solution, V is the volume. ठीक है, so n upon V can be replaced by C. C is the concentration of the solution. So pi equals to CRT. N क्या होता है? Number of moles. So how we calculate number of moles? Number of moles we calculate with the help of what? Weight upon molecular mass. So n की जगह मैंने क्या लिख लिया? यहाँ पर लिख लिया v, यहाँ पे लिख लो आप w upon m. ठीक है, this is substituted in place of what? n. So pi v मतलब pressure volume, this is what in place of n, weight upon molecular mass, gas constant T. Molecular mass equals to what? Molecular mass equals to WRT upon pi into V. Pi into V. This is what your formula in order to calculate the molecular mass of the solute particle. ठीक है? So this is what, how we can prove that yes, osmotic pressure, it's a colligative property. Because what is colligative property? We have studied in the definition that colligative properties are the properties which depends upon the number of the solute particle. So here we have proved that pi is proportional to m. It depends upon the concentration of the solution. So hence it's a what? Colligative. It is a colligative property. Okay. So now what is the advantage of this osmotic pressure? As I told you, in osmotic pressure we are taking the molarity, we are not taking molality. So advantages over the other colligative property is this, that osmotic pressure. This osmotic pressure as a colligative property is used to calculate molecular mass of macromolecule. हम molecular mass तो निकालेंगे, लेकिन मॉलिक्यूलर मास किसका निकालेंगे? मैक्रोमोलिक्यूल का निकालेंगे. मैक्रोमोलिक्यूल वर्ड आई इंट्रोड्यूस इन पॉलीमर चैप्टर. द मॉलिक्यूल्स विच आर हैविंग मॉलिक्यूलर मास हेवी, बड़े जो मॉलिक्यूल्स होते हैं उनको हम मैक्रोमोलिक्यूल बोलते हैं. सो इट इज यूज्ड टू कैलकुलेट द मॉलिक्यूलर मास ऑफ मैक्रोमोलिक्यूल लाइक प्रोटीन, पॉलीमर्स, एक्सेट्रा. ठीक है. एंड द मैग्नीट्यूड, मतलब इसका जो रेंज रहता है टू कैलकुलेट, द मैग्नीट्यूड इज मोर ओवर वेरी वेरी डाइल्यूट सोल्यूशन. सोल्यूशन बहुत ही ज्यादा डाइल्यूट भी होगा, देन ऑल्सो वी कैन यूज दिस प्रॉपर्टी टू कैलकुलेट द मॉलिक्यूलर मास. ठीक है. नाउ आफ्टर ऑस्मोटिक प्रेशर एंड दिस डेरिवेशन ऑफ द ऑस्मोटिक प्रेशर for the calculation of molecular mass, let's study the type of the solution. ठीक है. Hypertonic solution. ठीक है. अभी मैंने solutions बताया. Hypertonic solution. So what happened? For example RBC, मैंने red blood cells लिए. ठीक है. Actually what happens students, that in our body the medium of the blood in our body, the medium of the blood is alkaline. ठीक है. अल्कलाइन एंड द कॉन्सेंट्रेशन ऑफ द ब्लड इज 0.9, is concentration of our blood is 0.9% mass upon volume NaCl. अपने ब्लड के अंदर जो मीडियम रहता है उसका कॉन्सेंट्रेशन कितना है? 0.9 मास पर वॉल्यूम NaCl सोल्यूशन के बराबर रहता है. आगे बात समझ में. So this is the concentration. So that is why what happened, whenever any medicine is injected in our body, whenever any medicine injected in our body, through injection you can see that they are dissolving that solid substance in a medium in the injection. For example, if any solid medicine is there, then first the sister or the nurse used to dissolve that medicine in one solution, and that solution is having the concentration 0.9% mass per volume. ठीक है. इसको क्या करने से, डिसॉल्व करने से क्या होता है, हमारा सेल का कॉन्सेंट्रेशन भी 0.9 और बाहर के इंजेक्शन का भी कॉन्सेंट्रेशन कितना हो गया? 0.9 मास पर वॉल्यूम. तो दोनों को जब अपन वो मेडिसिन को जब बॉडी में इंजेक्ट करते हैं, सो बोथ द सोल्यूशन, medicine and blood, having the same concentration, and that set of the solutions which are having the same concentration are called isotonic solution. ऐसे दो solution जिसमें दोनों में concentration same है, या मैं दूसरी लैंग्वेज में कहूँ, if both the solutions are having same osmotic pressure, is called isotonic solution. And now it is very safe for intravenous injection. ऐसी मेडिसिन अगर हमारी बॉडी में चली गई तो इट इज सेफ फॉर द इंजेक्शन, बिकॉज नो ऑस्मोसिस विल टेक प्लेस, नो एंड ऑस्मोसिस, नो एक्स ऑस्मोसिस. I will explain these two terms just now what I use, end osmosis and X osmosis. So I think this is clear to all of you what is isotonic solution. ठीक है. So after isotonic solution come to the hypertonic solution. Hypertonic solution मतलब क्या हुआ कि मैंने RBC लिया. ठीक है. It is dipped in the solution and that solution is having the concentration more than 0.9 mass per volume. मैंने आरबीसी निकाला और एक बीकर में डाल दिया आरबीसी, एंड इन दैट बीकर द सॉल्यूशन कॉन्सेंट्रेशन इज ग्रेटर देन 0.9, मतलब बाहर का कॉन्सेंट्रेशन ज्यादा. आर यू गेटिंग द पॉइंट? आउटसाइड द कॉन्सेंट्रेशन इज मोर एज कंपेयर टू द इनसाइड दिस आरबीसी. बाहर का कॉन्सेंट्रेशन ज्यादा, अंदर का, then what will happen from RBC solvent will move outside because बाहर का concentration ज्यादा है, सेल के अंदर पानी ज्यादा है, तो क्या होगा from the RBC water will move outside and this RBC will shrink. It is very important reason beta, many times it has been asked in CBSE 12th class final exam for 1 mark question. What happened when RBC cell, red blood cells are dipped in more concentrated solution or hypertonic solution? Remember, RBC will shrink. When it is dipped in concentrated solution or the concentration greater than 0.1, then RBC shrink. Why? Because, remember beta, because from RBC water moves outside. अंदर से पानी बाहर आया तो क्या हुआ, धीरे धीरे करके आरबीसी श्रिंक हो गया. ठीक है, सो दिस इज व्हाट नाउ देन दिस इज कॉल्ड व्हाट एक्स ऑस्मोसिस. दिस इज कॉल्ड एक्स ऑस्मोसिस इन विच वाटर मूव्स फ्रॉम सेल टू आउटसाइड, फ्रॉम द सेल टू आउटसाइड. दिस इज कॉल्ड एक्स ऑस्मोसिस. ओके, दिस इज कॉल्ड एक्स ऑस्मोसिस. ठीक है, okay. Now the next one is the hypotonic solution. Hypo means come. So here the RBC is dipped in the solution. The concentration is less than 0.9 mass per volume. इसका concentration कम है 0.9 से, मतलब outside water is more as compared to inside. Once again I am telling, in hypotonic solution means RBC is dipped in a solution. This solution's concentration is less than 0.9 mass per volume. NaCl solution concentration कम मतलब salt कम, पानी ज्यादा. So क्या होगा, पानी यहाँ पर बाहर ज्यादा है, सेल के अंदर पानी कम है. So इसमें मूवमेंट क्या होगा, from outside to inside, बाहर से पानी सेल के अंदर गया. Okay, movement of the water molecule take place from beaker to the cell through semi-permeable membrane. This is called endosmosis. This is called endosmosis. Okay, अब धीरे पानी अंदर जाने लगा, slowly and slowly cell expands, swells up, है ना. सेल के अंदर पानी जाने लगा, slowly and slowly that cell, RBC cell will swells up and ultimately it can burst also. This question was also asked. धीरे धीरे वो उसकी मेम्ब्रेन फूलती जाएगी और एक स्टेज ऐसी आएगी कि it can't withstand the pressure and that membrane can burst also. So this is also okay harmful. So that is why in order to inject any medicine, it is very must that the concentration of that injecting medicine should be 0.9 mass per unit volume. अगर इससे ज्यादा होगा तो भी पेशेंट के लिए हार्मफुल है, पूरे सेल आरबीसी श्रिंक हो जाएगी, डेथ हो जाएगी पर्सन की. और अगर कॉन्सेंट्रेशन कम है तो भी क्या होगा, आरबीसी सारे सब स्वेलिंग होने लगेगी और एक स्टेज आएगी कि सेल सारे फट जाएंगे. सो दिस बोथ प्रोसेस आर रॉन्ग व्हेन बिफोर इंजेक्टिंग द सॉल्यूशन. सो आई थिंक दिस इज क्लियर टू ऑल ऑफ यू. हाइपोटोनिक समझ में आ गया, हाइपोटोनिक क्लियर, आइसोटोनिक क्लियर. In case of isotonic, both the solutions are having same osmotic pressure. In case of hypotonic solution, difference of osmotic pressure is there. Hypertonic also, difference of osmotic pressure is there. Now see what happened. One more application is there. The person, those who are intaking salt very much, consumption of more amount of salt in food. What happened? If you are intaking more salt, salty food if you are consuming, then the tissue of the body starts swelling. बॉडी के जो टिश्यू रहते हैं वो धीरे धीरे क्या होने लगते हैं, स्वेल होने लगते हैं. बिकॉज सेम वही होगी, बॉडी के अंदर सॉल्ट ज्यादा, टिश्यू के अंदर सॉल्ट ज्यादा, तो कॉन्सेंट्रेटेड सोल्यूशन हुआ और ऑस्मोसिस होते होते क्या हुआ, वाटर टिश्यू के अंदर ज्यादा आने लग जाएगा और धीरे धीरे टिश्यू क्या होंगे, स्वेलिंग होने लगेगी. सो ऐसे पेशेंट की बॉडी में स्वेलिंग होने लगती है एंड वन डिजीज दैट इज कॉल्ड एंजिमा. ठीक है, दैट डिजीज इज कॉल्ड एंजिमा. Now the next application is in case of formation of the pickle. जब raw mango लेके pickle बनाते हैं, when the pickles are made, so in the pickle solution the concentration of the salt is more. You remember, just ask your mother, when the pickles are made, raw mango are dipped in the solution in which the amount of the salt is more. Why it is so? That salt help in what? In order to preserve the mango, because outside the concentration of the salt is more. So from the raw mango excess of water comes out. Mango में से, raw mango में से water बाहर आ जाता है because outside salt is more, and in this way mango is what? Preserved for a year or more than year. So is the application. Then flower, wilted flowers, सूखे हुए flower. You have the experience, wilted flowers, if you are dipping in fresh water, it revives. अगर फूल मुरझा रहा है उसको आप पानी में डिप करके रखो, that flower revives, it become fresh because water movement take place from outside to inside the flower through the cell membrane, that is semi-permeable membrane. Next one is salted meat. In order to preserve the meat also, salted, salt लगाकर रखते हैं उसको. That the reason is same, that from the meat extra water comes out and it is preserved. Same is the theory for in order to make the jam, fruit jams and all that. That fruits, sugar coated fruits are preserved. Same, extra water comes out. ठीक है? And in this way what happened, in all these cases, pickle, that salted meat or the fruits, what happened, that bacteria, if any bacteria is going to attack, then because of the excess medium of the sugar or excess medium of the salt, from the body of the bacteria also extra water comes out, and because of the osmosis, and bacteria there itself dies. Okay, so these are the some applications of osmotic pressure, osmosis and all that. So I think it's clear to all of you that what is osmosis and osmotic pressure. So that's all in this video. To get the notification of next video, don't forget to subscribe this channel.